Today's experiment is on mirror stereoscope. What is mirror stereoscope? Mirror stereoscope is an arrangement of mirrors with the help of photograph. Which photograph? Aerial photograph. These are special photographs. For our experiment, we are using a specified scaled aerial photographs. So, we will start with the title. Title of the experiment is determination of air based distance using mirror stereoscope. What is air based distance? Photographs are captured on a air, meaning in a space. That is why we point to trace out 2 points on 2 different images. I mean one point on one image, another point on another image, which is having a same point, that is overlapping. Example, for example, if you consider our campus, entrance is one point which is captured through one of the images. In successive image, the same entrance is again happen to be overlapped. Then those 2 points should be marked as A or whatever notation you want to prefix, say P, P1. P is on at one image, P1 is on another image. Both the points are in a same overlapping images. So then how to find and those points are called air base point or air station points. Why we called air station points? Because we are focusing on that particular point and we are try to find the actual scale of the photograph. We capture the images, but there are tilting is there, there are drifting is there. So that is why overlapping is freeze. 30-degree camera is inclined, say this is the straight relation. When you incline the camera 30 degrees, then we can capture the very good images. When it moves onwards, it captures the images with overlapping. If it is the lengthwise direction, then 60% overlapping is allowed. That is why we are trying to trace the same points on both images, and we marked it. After marking it, we place mirror stereoscope, and after placing mirror stereoscope, parallax bar is to be placed to find the actual air base distance. Air base distance is the distance which is tracing through the images captured through the flight and which is percolating directly to the ground. That is why we call it the air base distance. If the images is captured on air, how to measure then air base distance? By using an instrument called mirror stereoscope and parallax bar. Mirror stereoscope which shows the actual images, overlapped images into the mirrors. Through the mirrors, both the images look like a single point, which will show in through the instrument. And next thing, parallax bar, it is a bar which is having a two end, one is fixed end, where we one image we capture, we fix the point, say P, we want to trace the P1 point. Then bring the initial reading of the parallax bar to 0, then after bringing 0 and trace another movable bar, so that we rotate the drums. After rotation, when we come across that particular point, we need to stop the rotation. Each revolution will be 100 meters, and the parallel distance considered as 1 kilometers. So that will be shown in the with the help of instrument further. Here we are using the formulas. Aim of the experiment is finding of air base distance using a mirror stereoscope, and the formula is air base distance is equals to mean distance. Why we called it as a mean distance? Because we are using a successive 3 readings. That is why we are using a mean of that into scale. Whatever images we use for this particular experiment, it is already having a particular specific scaling. If it is unknown scale, then it is not possible to perform the experiment. That is why we are required to, we need to have a scale as well as mean distance. Distance we will calculate through the mirror stereoscope and parallax bar. This is our setup for mirror stereoscope and finding the air base distance. This red color instrument is known as mirror stereoscope. We will go through the components first. This is this instrument legs, which is having a 2 legs right side, 2 legs left hand side, and we will be having a leg adjustment through these screws. Here also there is a screw, there is a screw. This adjustment is to find out the air base distance which is overlapping. This required little bit time if you are not operated this instrument earlier. So this take 5 to 6 minutes to adjust the instrument, and these are the lenses. If you see here, there is another glass. The images, for example, I have pointed out the one station point here and same station point is marked here also, this one. So, we are finding the air base distance of both the points. In this glass there is a plus sign which indicates the our air base station, and this is a fixed leg of parallax bar. This is rotating drum. Here if you see again, there is a graduation, each graduation is marked out to be 1 kilometers. Then there is another movable leg which moves inward and outward based upon the drum movements. So, this is the basic of the components of the equipments. Then we will try to perform this experiment right now. Now, I will exactly fix the plus sign on the one particular image, because both the images having the same point. Let's say this is point P. Parallelly, we will be noting down the readings P to P1 distance. Here it is a P, say this is a P point. Here mark point is P1, but it is the plus point is not exactly on that. So, here initial, if you see your drum, there is a 0 0 graduation, it should be 0 0, and again if you note this one, here also it should be 0. If it is initially some values, then we need to consider those values. I kept it as a initially 0 0. Then I will try to rotate and bring the second movable leg. This is a movable leg. We will try to bring to closer to the exact point of the another station point P dash. This will not move, this fixed point will not move. Now I am rotating the drum. You can see it parallelly. The point, the movable leg is moving. If you look at this, this is slowly moving. So I am trying to bring the point here. If this drum has 100 graduation, once complete means 1 kilometer is completed. So I am trying to bring the another point, movable leg. Already crossed one drum, and this is second revolution. Okay, we are trying to bring the location exactly. 2 revolutions happen, this is third revolution, and we are near to the point. Yes, if you look at this now, plus sign is exactly on the another mark station point. So, here it is again marked. Now, we will tell you the readings. Here on a second line, that means 2 kilometers, and here third drum is rotating. Third drum we have stopped at exactly 80 number, that means 800 meters. That means total distance at the final is 2800 kilometers. This is initial reading, first trial. Now, we will consider second trial. Again I will bring to 0. After the readings, we got a 3 set of readings, and based upon the 3 set of readings, we are going to calculate the air base distance by using the particular formula. Here we have got 3 readings for the same point, and we got the respective values, that is PP1, that is 2800, 2820, 2820. These are the 3 set of readings we got from the same points with the mirror, stereoscope and parallax bar. Then mean will be this one, the mean value is 2813.33. By using this mean value, we are going to calculate the air base distance of that particular points. Here you can see air base distance is equals to mean distance, that is this mean distance into scale. Scale is already known to us. Photo scale of this photos is 1 upon 10,000. So, when you multiply mean distance into photo scale, we got this particular value. When you can multiply with 100, you will use the 281.3 meter, that is air base distance. With this, we can conclude that every exposure point is 281.3 meter, we got a exposure of cameras. So, thank you.